Your OpenAPI spec has dozens of endpoints, but you only want AI models to access a carefully curated subset. We'll show you how to explicitly allow list specific routes while excluding everything else, using a catch-all exclusion rule that blocks any endpoints not explicitly mapped. This pattern gives you precise control over which API functionality gets exposed to AI clients. From FastMCP, import FastMCP. From FastMCP, server, OpenAPI import RouteMap, MCPType. MCP equals FastMCP, from OpenAPI. OpenAPI spec equals spec. Client equals client. RouteMaps equals. Hash custom mapping logic goes here. Hash your specific route maps. Hash exclude all remaining routes. RouteMap, MCPType equals MCPType, exclude. This demonstrates the declarative routing pattern for API to MCP transformation. The code shows how FastMCP converts OpenAPI specifications into MCP components using configurable route mapping rules, rather than hard-coded endpoint definitions. What makes this distinctive is its rule-based system that processes routes through ordered matching criteria, allowing precise control over which API endpoints become MCP tools, resources, or templates. The pattern works by applying a hierarchy of route maps that evaluate each OpenAPI path against method, path pattern, and tag criteria. This declarative approach separates routing logic from implementation, enabling you to define conversion rules once and apply them consistently across entire APIs. The system processes routes in order, with the first matching rule determining the component type, and supports both inclusion and exclusion patterns for fine-grained control. This approach solves the common problem of API bloat in MCP servers by letting you curate exactly which endpoints are exposed. It's particularly valuable when integrating with LLMs, where too many tools degrade performance, or when you need to hide internal endpoints while exposing public ones. The trade-off is that you must understand your API's structure to design effective route maps, but the payoff is cleaner, more maintainable MCP servers that match your specific use case. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI callable tools. It bridges your Python functions to AI models by generating OpenAPI-compatible schemas and handling the RPC layer. From FastMCP, server, OpenAPI import RouteMap, MCPType. Imports RouteMap and MCPType for OpenAPI route filtering. These define inclusion-exclusion rules when mapping API endpoints to FastMCP tools, giving you precise control over which operations become AI callable. MCP equals FastMCP, from OpenAPI. This instantiates FastMCP from an OpenAPI specification, automatically converting API endpoints into AI callable tools. The factory method handles schema validation, type conversion, and tool registration in one step, eliminating manual boilerplate for each endpoint. It's the standard entry point when integrating existing APIs with AI systems. OpenAPI spec equals spec. This passes the OpenAPI specification to FastMCP, defining all available API routes, parameters, and schemas. The spec dictates which endpoints exist and how they behave, ensuring the MCP server matches your API's contract exactly. Without this, FastMCP wouldn't know which routes to expose or how to validate requests. Client equals client. This injects the HTTP client instance that FastMCP will use for all API requests. Without it, the MCP would have no way to communicate with your server endpoints, making the entire toolset non-functional. This follows the dependency injection pattern for explicit, testable configuration. RouteMaps equals. This defines the route mapping configuration for FastMCP. The list specifies which OpenAPI routes to include, modify, or exclude when creating the MCP instance, giving you precise control over the exposed API surface. This is where you implement custom routing logic or security filtering.
Hash custom mapping logic goes here. Hash your specific route maps. Hash exclude all remaining routes. RouteMap MCPType equals MCPType exclude.
This is the route filtering pattern in FastMCP. The placeholder comment indicates where you define custom route mappings, while the final route map, MCPType equals MCPType. Exclude ensures all unspecified routes are explicitly blocked, preventing accidental exposure of sensitive endpoints. This whitelist by default approach enforces security through explicit configuration. This closes the route maps list, finalizing the route configuration for FastMCP. Without this, Python would expect additional items, causing a syntax error. It's the standard list termination pattern in Python. Closing parenthesis terminates the FastMCP. From OpenAPI, call, finalizing the configuration with your custom route maps. This is where the actual MCP instance gets instantiated with all specified settings, ready for use. Route mapping philosophy. The catch-all exclusion pattern in FastMCP demonstrates how absence becomes the most powerful rule, silently defining what exists by declaring what doesn't. A final exclusion route map, without any filters, will override all default mappings, making it the ultimate allow list enforcer. This pattern gives you surgical control over API surface area, while maintaining clean, declarative configuration.
The route that matches nothing controls everything.